So here's a problem that everyone needs to know how to do, which is find the zeros of this function. Notice that the function is a quartic function. It's a fourth degree, and that tells you, let me change the color here, that tells you that you could have up to 4 zeros. You might have less than that. You might not have all real zeros. There might be imaginary. So for instance, my graph, in fact that's what I'm going to tell you to do, graph it. Put it in your calculator, your graphing calculator, if you're allowed to do that, and you'll notice I'm going to just kind of sketch the graph here. You'll notice that the graph does something like this. It goes up there, it goes down here, and up here like that. Actually, it crosses more at that point. And so I can see, remember the rational root theorem? It says P over Q. You remember the P and the Q? The factors of the constant term are P, and the factors of the leading coefficient are called Q. And if it has a rational root, then it's of the form P over Q. And why does that help us? Well, because when I look at my picture, I can see, oh look, that looks like 2, and that looks like 3 right there. So those are 2 of my zeros. 2 and 3 are 2 of my zeros. So how would I find the other zeros? By the way, what are the other zeros? Are they nice, pretty numbers?
No.
No, they're imaginary. You can see that they're imaginary because it doesn't. This goes off to the left and to the right, and it never comes back down and crosses the x-axis. And so most likely these are imaginary, or even possibly, I guess this could have been, one of these could have multiplicity higher than 1. Like they could have had a multiplicity 3. So let's find it. How do we find the other ones? Well, we use synthetic division. So I'm going to take 2, and I'm going to take my coefficients, and I'm going to set it up and do synthetic division. Bring the 1 down, multiply by 2, negative 3, multiply by 2, add down, multiply by 2, bring it down, multiply by 2, and there's your answer, 0. And guess what that means? That means that 2 was in fact a 0. And what other one do I think is a 0? I think 3 is a 0 also. So now use your remainder to do synthetic division again. Don't start all the way over. Use what you have to do synthetic division again. So let's do it. 1 comes down, 3, 0, 0, 1, 3, 0. And how nice. Because this right here tells me that my other quadratic is x squared plus 1. So what does this equal up here? That equals, I'll write it over here, f of x equals, let's write it as a product of linear factors. What linear factor comes from the 0 of 2? X minus 2. If x equals 2, set that equal to 0, what do you get? X minus 2. What linear factor comes from the 0 of 3? X minus 3. And what are my other two? X squared plus 1. Now, do they want, the direction says write it as a product of linear factors. So, am I done yet? Is this a linear factor right here? No, that's not. That's a quadratic factor. So I have to do what? Set it equal to 0 to find the other zeros. And what are the other zeros going to be? X squared equals negative 1, which means what? X equals plus or minus. What's the square root of negative 1 mean?
I.
It means I. So what's my product of linear factors? I'm going to write it up here. This is my final answer. Let's write my final answer out. F of x equals x minus 2, because 2 was one of my zeros, times x minus 3, because 3 was one of my zeros, times x minus I, because I is one of my zeros, times x plus I, because negative I is one of my zeros. And that's my answer as a product of linear factors. Okay?